VCE Chemistry, Unit 4, LS 1, High Performance Liquid Chromatography. So in this video, let's zoom in to look at the details of HPLC, and then how do we use a calibration curve to determine the concentration of organic compound in a solution. Now, HPLC has the same principle as all other chromatography. The only thing is that it's very sensitive, so the compounds in trace concentrations as low as like ppt, like parts per trillion, can be identified. It's also able to operate at low temperature, which means that we can use it to analyze substances that are unstable at a high temperature, which is basically all organic compounds. Okay. So first of all, you notice that we need a pump to push the liquid through the high resisting stationary column. And that's also part of the reason, like the column is really compacted. That's why we need a pump to actually push it. Let's look at closer. So sometimes we have a non-polar stationary phase and a polar mobile phase. It can also be swapped. It's not set in a stone. Okay, it really depends on what you want to use it, but a lot of times it's non-polar stationary phase and polar mobile phase. The mobile phase is also called an eluent, using water and methanol. Okay, the stationary phase is a waxy porous substance that you can imagine. Okay, it's a little bit porous but waxy. It allows the eluent to be passing through very slowly under high pressure. That's why we need a pump there. And the small particle size allows greater absorption and desorption by increasing surface area in this as the solid stationary phase. That's why it can be really sensitive. It's very good with detecting and separating substances. Okay, that part. And the detection part is basically here. Okay. So once the substance comes out, there's a detector and then translate to a recorder, which produces a chromatogram. It's a little bit similar to UV vis in the detector. It's basically a stream of liquid passes through a beam of UV light. The detector on the other side of the light that measures the percentage of light absorbed. And this is calibrated to the mobile phase, so that mobile phase will have zero absorption, and then all the other substances in the mobile phase that comes out from here will have their own absorption. That absorption creates that chromatogram. Now, for qualitative analysis, so basically knowing what stuff are in a particular sample, we use retention time. So it's defined as the time taken for a component to pass through the column. Okay, so it is characteristic of each component for a particular condition of the experiment. That's why it's really good for qualitative analysis. So what we do is, first of all, we need to have a standard sample of insulin. For example, if we want to test if a drug has insulin in it, then we need to first have a standard sample of insulin, create a chromatogram under that same experimental condition. Right. And then we run the sample through the same machine and the same condition, and we know we're basically looking for peaks with same retention time. Okay. If they have same retention time, that means that if that's the retention time for insulin, and you have the same peak at the same time, that means that this sample does contain insulin. So basically, that is for qualitative analysis. And you notice that a retention time does depend on molecular structure, temperature of liquid, length of column, stationary phase, and pressure of the liquid as well. So we need to make sure that this standard chromatogram is produced in the same condition as the chromatogram of the sample that we want to test. Confirming insulin there. Now, for quantitative analysis, we need a calibration curve. Hopefully, you still recall some of the techniques of making a calibration curve from your study of UV vis in year 11. So for HPLC, what the machine does is that the height of the peak area corresponds to the concentration, or you can say the amount of substances within that particular sample. Okay, so using that feature, we can actually produce a calibration curve. That is, for example, for insulin, we just make 5 samples of insulin with different concentration, let's say from 0 to all the way to 0.06 micrograms per mil, right? And then we run it through the HPLC machine under the same condition. Then we should have different peak area being obtained. And then we plot them on this entire graph. Then that's our calibration curve. Okay, so a calibration curve, once we have a calibration curve and then we can run a concentration of the unknown sample. Let's say, for example, in my sample, the peak area corresponds to 6.0. Then I find 6.0 on the calibration curve and go back to find out the concentration of a particular for example, in caffeine in this case, the concentration of caffeine in the unknown sample.